Today, if you guys recall, we are picking up in the middle of going from our condenser towards our metering device, right? So we're talking about our hot gas line, liquid line. We covered ambient, low ambient cooling, the A8, A9, that's kind of where we left off. You guys remember in this? Receivers. We're talking about that receiver, we're talking about the pop-offs, all that good stuff. All right, so to bring us back on this chunk, the next thing I want to talk about is a feature that is not on every rack. In my opinion, it absolutely should be. It's just one of those things. Sometimes we've got racks that have this, sometimes we don't. It's a very, very powerful maintenance item. This is my surge or ambient subcooler is what it's called. That's how it's labeled, right? For us, as technicians, the way we think of it is receiver bypass, right? So if I need to work on that receiver and I've got this receiver bypass, I can valve off my receiver, open this system up, and my rack can continue to run while I'm doing that. If I don't have this and I've got to isolate my receiver, I have to shut down the rack. There's no way for it to continue to run. So my drop leg comes through here. This is my holdback valve, if you guys remember. And then I've got a T here. Well, this T is my normal flow of refrigerant, and that goes into my receiver, okay? Well, we can see we've got this thing right in front or past downstream of that T. This is a solenoid, that's all it is. And if this solenoid is open, that will allow that liquid to flow past the inlet to my receiver. It's gonna flow into my dryer and then onto my cases, right? If I close that, which is its normal state, my liquid's gonna run into my receiver and then it has to go all the way through the receiver and come out in order to continue its adventure, okay? So normally that's closed, but there's a couple instances where I may wanna use that. Talk about this solenoid. This is something that Corey found the other day. So this is an E42, it's an E-series solenoid, it's kind of what we call it. The E42 is specifically what we run into. We're gonna find this solenoid, this is like any other solenoid, as far as it just opens and closes based on a coil, an electrical signal, right? Create a magnet, that makes the metal thing move, and that opens and closes it, right? This particular one is normally closed, just like all the other ones that we typically run into, except for that condenser so far, right? It's the only one that was normally open. So it's normally closed. So what's special about this guy? Well, the big tell that we've got one is this pilot line, right? A solenoid normally does not use a pilot, okay? This particular one does, and its advantage is it is a pilot operated solenoid, which means I've got a little tiny movement. I don't have to move much. I'm just moving the pilot pressure is all I'm controlling. Then the pilot pressure drives the great big thing, right? Well, what that gives me is very little pressure drop, right? A normal solenoid has a significant amount of pressure drop. So we want to use this valve in an application where we don't want a lot of pressure drop. This is one example, the liquid line, right? Another would be EPR.
Yeah.
Right? So if we have a pressure drop on an EPR, we've talked about suction and how expensive that is. Well, if I've got a pressure drop across the EPR, I've got to run my rack even lower pressure. So I want a very little pressure drop. So if I'm going to use a suction stop, solenoid, not an EPR, right? Not an electronic valve that we're closing, I'm going to use this one, okay? So we're going to see this valve in a couple different places. One is right here on my surge because I don't want to eliminate that. I don't want to have a pressure drop when I'm using a holdback valve and our pump up valve, which we covered last week, right? To manage that pressure very well, get it right where we want it. I don't want this valve to mess that up, okay? So I want as little pressure drop across it as I can get. We're going to see that in this surge. Now there'll be a manual service valve also for us, as technicians. But when we go to open that valve to work on a receiver, don't forget this is a normally closed solenoid. It won't be open. right? So when we open our service valve, nothing's gonna flow in most situations. So we got to find the control for this in the EMS system and force that valve on, right? And we do want to force it even if we find it on, because we don't want it to automatically turn off while we've got our receiver valved off, right? Does that make sense? So we want to find that, and we want to force it, and we want to cause it to stay open while we're working on the system, all right? So here's the concept. All right, so here's another store, same setup, right? There's my drop leg. My liquid is flowing into my receiver. It's hitting this solenoid. Solenoid's closed. Then my liquid is going into my receiver. Now, my condenser, if we remember, is not creating much subcooling. Right? It will in air conditioning. It's just not going to in the rack system because I'm not stacking unless I'm doing that through ambient holdback, right? If my ambient temperature is falling and my holdback's in play, that's the only time that I'm stacking in my condenser. Most of the time I'm not stacking, so I'm not getting much subcooling, which doesn't matter because I'm flowing into my receiver, which has vapor and liquid, so I'm at saturation, so I'm gonna lose all of my subcooling, so it doesn't make any difference, except that one scenario I just said. Low ambient, my holdback valve comes into play, and I am flooding my condenser. We covered this last week, just reminding you, right? So I'm flooding a little bit there, and I'm getting subcooling. Well, when I start flooding a lot, I get a lot of subcooling. I get a ton of subcooling, right? In that scenario, I don't want to lose my subcooling, right? Because I'm generating a lot of it. It's a byproduct, right? It's not on purpose, but now that I got it, I don't want to lose it. So in order to not lose it, I can't go to saturation. I can't have vapor and liquid together in the same place, right? When the PT chart applies, and that change in temperature equals change in pressure, and this is not good. I want to avoid this. So that's when my, quote, ambient subcooler is going to come into play, all right? I'm going to open that solenoid and allow my liquid to bypass my receiver so I keep that subcooling. Make sense? Right? I'm going to do that right up until I go through all my fans turning off, my 50% shuts off, turn on my fans again, I cycle all of them back, and then my holdback valve comes into play. When my holdback valve comes into play, now I'm managing that pressure. I have to have my receiver from my hot gas pump up to work, right? Or I'm going to be pumping up the other side of the holdback. It's not going to be holding back. That won't work. So when I get to that pressure and I energize the solenoid on my holdback valve, I'm going to de-energize this again. I'm going to shut this off again and force that refrigerant back into my receiver, right? So that's why we call it the ambient subcooler. It's giving us subcooling when we have low ambient, right? That's the point. You'll also see that labeled as surge. We don't close the receiver. Okay, that is an important part of this. We don't close the receiver. We only open the bypass. So our liquid is going to take the path of least resistance, but if our system becomes, quote, overcharged, I still have the receiver for that refrigerant to go to. So it's not going to increase my pressure like a critically charged system would, right? So how would that happen? Well, I stop holding back, right? I've packed a bunch of liquid up into my condenser, and then it warms up. Okay, then I've got all that liquid coming back. Or I go to 50% split and I pump all that refrigerant out, right? That's going to be a change in charge. Well, if I'm in this mode, I've got to have somewhere for that extra refrigerant to come from and go, right? So I'm going to leave the receiver open. If I need it, it is there, but it's going to follow the path of least resistance. If I don't, then I won't lose this up. That's kind of the idea, right? I see a quizzical look.
Wouldn't your, in my brain I was thinking the ambient subcooler was there and was opposite. Like when it's hot outside, you want to keep your subcooler. What little you do get from the condenser, not when it's cold.
Other way around. Right?
Wouldn't your receiver act as, if it's actually holding liquid, wouldn't it act as, you know, because you'd have liquid and vapor.
Right, you're gonna have liquid and vapor, you're gonna be at saturation, your PT chart applies. That's exactly right. So that means your receiver's probably gonna be warm, right? It's not gonna be cool.
How much does that actually affect subcooling?
Significantly. Yeah, you may get 1 or 2 degrees of subcooling out of your receiver. That maybe 4 in an extreme situation, perfect scenario. That's about all that you're gonna get. And that's gonna be because the container itself has been chilled a little bit.
Which you
Right.
lose a lot.
If you walk up to your receiver and put your hand on it and it's warm,
Got problems,
hey,
Jay.
come on, that's summer. That's every day in the summer. It's gonna have heat. Well, relative to my PT chart, what does that look like? It's gonna be very near saturation. It's gonna be slightly cooler, 1 or 2 degrees, typically, maybe 4, up to 4, right? Not much. Does that make sense? Now, as my ambient temperature changes, that metal vessel changes too, right? So that's gonna go up and down. You know, I'll have a little more at night and a little less in the day when the temperature's climbing. Yeah,
So we're activating that bypass solenoid in like what applications, like when it gets to
yeah. So when we're activating it versus the computer, right? The computer's gonna activate this when it detects my liquid leaving temperature coming out of my subcooler, which we're gonna get to, right? The liquid feeding my cases, I've got a temperature probe on that. When that temperature meets my setting for what I want that temperature to be. So in other words, if I'm subcooling at 50 degrees, right, I want my liquid going into my cases at 50 degrees. If I hit that, if I hit 50 degrees, I don't need my subcooler running. I'm gonna shut off my subcooler and I'm gonna open this valve.
So like, pretty much like around this time, typically, because
What's that?
typically around this time, it's usually
Cooler
because
outside.
the liquid,
Yeah,
cooler
so
outside,
it's gonna, the sequence of operation, the way this is gonna work for us, the way we're gonna see this play out is it's gonna be cool outside. We're gonna have shut off all of our fans, we're gonna have gone to 50% split. We've pumped that liquid out, we brought all those fans back on, right? And then we started shutting those fans off. Okay, somewhere in there, our drop leg's gonna hit 50 degrees. Okay, now it depends on my rack, right? My medium temp rack, subcooling may be as high as 70. We've seen that. So that may happen really early in that process. You know, as soon as I go to 50% maybe, I've got a 70-degree drop leg, right? When that happens, and my drop leg is at that leaving liquid temp requirement for my subcooler, I don't need the subcooler anymore, it's just happening, right? That's when I'm gonna fire that valve and bypass my receiver and keep that subcooling, because it's 70-degree liquid, that's what I wanted all along.
So that drop leg temp sensor that is always either cut out or bad is a very important.
Now you know its purpose, right? That's right. Now, does that matter in July?
I
Probably
thought it
not.
was just for approach, like if they were trying to calculate approach or something.
They are not a calculating approach. You're giving them way too much credit. Could they? Yeah, sure they could. They could do a lot of things with that, especially with VFD, right? You can use PIDs and all kinds of stuff. That's not what they're doing though. Yes, it's just more straightforward than that. Yes, sir.
So that's only gonna be activated, that bypass solenoid, when we're at 50% split?
It's gonna go off of temperature, right? But if it's set up correctly, that's the sequence that'll happen. But there is nothing that says I have to be in 50% for that to
But
happen.
the correct order of operations would be 50% split, then if that still isn't enough, then we activate that bypass solenoid?
So the bypass solenoid is a side effect of that.
Okay, so.
All right, so that low ambient bit that I covered last week is gonna happen regardless of whether we have this valve or not, whether this works or not. This is a side effect, right? So as we're working through that ambient system, when the magic temperature of my drop leg meets the temperature that my subcooler is trying to achieve, when those two things happen, and it can be a different pressure on different temperature on different stores. As you guys know, my subcooling settings are all over the place, right? But when those two numbers match and they align, my rack is gonna say, I don't need the subcooler, I need this, and it's gonna open this valve, right? So I may be at 100% on the condenser and it's just not set up well, okay? Yeah, that's possible, right? I could be all the way down to where I'm trying, just about to hold back, right? If it's a really cold, subcooler. We do have a few that are 20, 30 degree subcoolers, right? That's very rarely gonna happen. We're gonna be very close to holding back when that happens. But once I hold back, because of my A8, A9 problem, I'm gonna override that feature and we're going back to how we were. So it's really just that short span of when that temperature's just right.
So that applies in medium temp as well? Like,
Sure.
I know that
Yep,
the medium temp, like 80-degree
yep.
liquid lines.
Right. Yeah, and one thing about these, you're gonna find the surge ambient setup really common on low temp.
Yeah,
And not
that's
nearly as
fine.
common on medium for that very reason,
Yeah.
right? The other thing that you'll see is when we go to a VFD driving the condenser, we have one customer that really likes to do that. And they're abandoning that concept, but there's a lot of them out there that they have retrofitted, right? When they do that, they take control away from my EMS system for this valve. They remove it and they put it on the smart drive, on a smart VFD. Now, if I've got a dumb VFD, it stays, so it's all the same. But if I've got a smart VFD, when I say smart, I mean it's programmed and it's making decisions and it can control other things, rather than somebody telling it, run at 40%. That's a dumb drive, right? Smart drive is, I'm gonna measure this, I'm gonna measure this, and I'm gonna decide what percentage I wanna run. Well, I can also turn some switches on and off. All right, that setup, the VFD is gonna control my 50%. It's gonna decide when I go into 50% or not, and it's also going to decide when to open and close this valve, because it's measuring that drop leg temperature. That's where that sensor now goes. Okay?
So, this bypass system, is it normally open or normally closed?
So that bypass is normally closed, right? I'm normally flowing through my receiver. I only open it when my temperature is just right. Okay? Now, like I said, as a technician, it's a very powerful tool. If I've got a leak on that sight glass, we were talking about they inherently are crappy gaskets and they do leak a lot. If I've got this, all right, I can force this valve open and then open the mechanical valve, and now I can close off that receiver. I can pump it out. Okay?
Well, oh yeah.
With the rack running.
Yeah, so one, I feel stupid because I changed a couple of those gaskets, and I've seen those on there and never utilized that. I shut the system down, pump out the receiver, and change the gasket. So that's fun. But secondly, in like the middle of summer, for example, is that going to affect any repairability on it, or like anything, you know, what kind of issues could you find in like the middle of summer? I'm trying to replace a gasket on those, because I know it works in low ambient, but how does it affect itself if that thing's on? And not even just for repairability, just in general, like let's say that thing gets
What
stuck on.
could go wrong? That's what you're asking, right?
Yeah, basically, so I know it works well in low ambient. What are the consequences if that was activated in high ambient?
Right. Yeah, if this thing was on all the time, you know, our worst case scenario would be middle of summer, middle of the afternoon,
Yeah.
middle of summer, really hot, right? I got a lot of, so my danger here really is just potential flashing. If I don't have the subcooler sitting there to get saturation, right, it works both ways, okay? So think about this. If my condenser's not giving me a solid column liquid, right, and we're not flooding it at all, so there's a chance. If it's really hot outside, I don't have a solid column coming out of my condenser,
Yep.
right? If I have this surge valve closed and my liquid has to go into my receiver to saturation,
Yeah, you're forced to.
I'm gonna condense the rest of the way, right? Does that make sense? If I've got this open and that happens, I'm sending out that river of vapor to my cases, okay? Or at least to my subcooler, right? So that's my danger. There's the danger, right? If I have a mechanical subcooler, almost nothing, because I'm gonna subcool it anyway,
Yeah.
right? If I'm not feeding it with a full column of liquid, I'm gonna make it, right? But if I don't, I'm definitely gonna be sending vapor to my cases at times when the conditions are just right, okay? Or just wrong. Right, yeah, that's a good question. What can go wrong? So the other thing can go wrong, it doesn't open. Okay, that's the other, that's what happens if it stays open,
Yeah.
right? If it sticks open, sticks closed, what happens? We just lose that free subcooling, that's all. Okay, so it's an energy thing on the other side. Right? All right, any more questions about the surge ambient? That you've all seen, the toggle switch with piece of tape over and
Are these installed like on all Walmart racks?
no.
Never
No, there really seems to be no rhyme or reason to that, right? You know, so usually there's a rhyme and reason. It's this vintage that we did this, and then this vintage we didn't. Right, whatever. There is none of that, right? You can't look at it and say it's a 93, it'll have one. Some of them do, some of them don't. In modern racks today that Walmart's buying, some of them do, some of them don't. You know, I honestly don't know what that criteria is, why they decide to throw them in there or not. Some stores have them on all 4 racks, some stores only have them on low temp. You know, they are definitely more common on low temp. They're definitely more common on older stores. But like I said, modern stores today, most of them have it. So,
And last question, just to clarify, so your surge valve, ambient subcooler, interchangeable terms?
yes.
Okay.
Yeah, exactly. That's why I put both of them on here. You
Yeah.
will see both of those names, right? Yeah, I don't know
And
why.
receiver bypass, same thing?
Yeah, receiver bypass. And as technicians, we think of it as a receiver bypass. That's what we tend to call it. And that's why I wanted to cover this with you, because you've seen surge and you've seen ambient subcooling and you've heard guys talking about receiver bypass and not put together. This is all the same thing, and we're doing the same thing, yeah. So my liquid, and this isn't on my drawing, right? This is my bypass. This is where it would be in this drawing. It would just leave the receiver out, okay? So after that, we come down here, guess what? We're hitting filters, okay? So let's talk a few minutes about filters. That's my filter shell, right? In a rack situation, we almost always are gonna have a shell. Usually it's gonna be a 2 cartridge, sometimes even a 3 if it's a large system. Seen a few 4s, big boy, right? 1,600 pound type system. Yeah, they're there. Okay, so just a couple pieces I want to talk about. I'm not going to go, this isn't a class on filters, right? I just want to cover a few key components here that as technicians, what do we run into? Well, I like this drawing, or this cutout. I took this from Sporland. One of the questions that I hear guys coming up with is, you know, when I pull out a cartridge, it's got a taper on one end. Which end, is that inlet or outlet?
Outlet.
Right. So if we look at Sporland's, this is the manufacturer, right? They're telling us, there's my little cut. Damn, if it isn't the inlet, right? Yeah.
It doesn't matter.
Okay, but here's
All right.
the thing.
It probably doesn't
It's
matter.
because that's an internal screw.
Okay.
Well, and then
All
they
right.
have.
So what Chad just said, and that got a little discussion going, because everybody's got an opinion, right? That got a little discussion going. What Chad just said is the correct answer. It doesn't matter. All right. So let's think about this
Some
for
of
a
them have
minute.
them and some of them don't. You can get them. I've seen them
Leave 'em out.
straight.
What are they straight? So this is my inlet. This pipe down here is my inlet, always on these canisters. I'm coming in the side, right? And then my outlet is the piece that's in line with the whole shell, okay? So that means I'm filling the entire outside of this thing with my inlet refrigerant. In order for my refrigerant to get to the exterior, it has to flow through the sides of the core.
To the inside.
It's not running through the middle, and that's kind of how we think of it, right? It doesn't shoot it through the center or anything like that. It doesn't flow end to end. It's coming from outside into the middle. That's how it actually works, right? And when we're sitting there with these things, we don't think of it that way. We think of it as it's shooting through somehow, right? It's just not. It's coming from the outside in. So these bevels don't matter. They're to make sure it doesn't get stuck and we can get it out. That's all it is, right? So it really doesn't matter. Now, what does matter? There's a few pieces that do. All right, I got this plate on this end, and I got this plate on this end, I got this plate in the middle. Well, since I just said all the refrigerant has to go through the core, that means if I don't change those gaskets and I don't have a nice seal there, I'm going to give that refrigerant a path of least resistance. It's going to go around my core. It's not going to do anything, right? The other place that's critical is on this end, and this spring is driving that seal on the far end, right? If I don't have that pressure correct and I don't have that gasket in place, I'm going to bypass it. the other thing that I really want to just take a few minutes to point out here is there is another element to this that we don't normally use. And this is this core that slides in the center, right? Every one of these can take another filter, a secondary filter, okay? We don't run them because they tend to get dirty. Well, isn't that kind of the purpose?
No.
All right? So let's think about that for a
Probably
minute.
wouldn't clean as many screens if that guy was in there.
All right,
Yeah.
say it again louder.
Probably wouldn't have to clean as many expansion valve screens if that was in there.
All right, so when we've got a dirty system and we're cleaning screens, right, when we're constantly finding dirty screens and we want to clean this up, right, we talk about, well, I'm going to clean this up. How am I going to do that?
Pressure locker?
We're going to add this core. We're going to add this center core. All right, now.
Does that come with the initial system? Or is that?
No, you have to order it extra.
Okay, I was just saying,
Extra.
I feel like maybe it just gets taken out on the first initial change.
No, I love this screen.
Right. So you guys know we're changing dryers as part of our spec. You know, just about any time we touch anything, we're swapping dryers in and out of there. If it's an extra special bad setup there, we may want to work with the store and put one of these in there. Now, we can't leave it. That's the point, especially if it's dirty. Okay? Now we can. If the system's clean and it doesn't need it to begin with, it's not going to stop up.
I mean, you know,
But why are you doing it then, right? If you're putting it in a system that's bad, it's going to stop it up. It's, you know, there's no question it will. So I've got to take it out, right? I want to run it, let it do its job, and before it creates a problem, pull it. Maybe put another one, you know, until I'm clean. Yeah.
so if you move your mouse or your pointer down to the bottom screen, I just have a question on that. Like right,
I have one of those.
This one?
so yeah, at the end, right there. So that
Yep.
you can see a little black gasket. Some don't have them.
Yeah.
So I've been putting the gaskets that come in the filters.
Kit. Yep.
There's one that fits just kind of snug. Like those are pretty important, I assume.
So what you've got to seal, what you have to seal, is that plate has to seal to here.
So that it is important.
Yep. Critical. So yes.
And the gaskets between the dryers.
Yeah.
And each
Yep.
plate,
Yep.
each side of the, everywhere there's a mating surface.
That refrigerant must flow through the container itself, right? That whole core through the outside side, not the inside, right? Not the hole in the middle, through the outside. There's resistance. There's going to be a pressure drop there, right? So if one of those gaskets is not sealed, it's going to go around it. It's going to take that path of least resistance. So it's got to be sealed at least to a few pounds, right? I mean, it's not going to be 20 because we're changing them if it's that bad.
All right, so you can settle this once and for all for my brain. Since it needs to be sealed, because this has always been a debate with me, is that you'll find the cores that come with the paper gaskets
Yep.
like normal, but then you'll also have the ones with those like felt
Yeah.
white cotton
Same thing.
gaskets.
Right.
So obviously that's not sealing nothing, and it's allowing stuff to pass through, which I'm assuming is to catch like pieces of little desiccant and whatnot.
Yeah,
But-
your bigger chunks, right.
So what's the deal with that then? Because Sportland, none of their stuff, do they specify any difference between the two, or why they come with paper gaskets and some come
Usually
with?
the only ones the dryers that I've noticed, the only ones that actually come with new felts are the Danfoss ones.
Yeah, I found them in a random box. That's the only reason I have them in my truck. But I'm like, I never know
and new
if
paper
I see the old ones, if I should put the paper ones in, if that's better, or if the felt ones should go back in, or what, because it's not sealing anything.
Right. So it's more of a, this isn't on Sportland, right? So this is not this picture. This doesn't apply, right? On the Sportland setup, there's no felt, right? If someone's running a felt, somebody's added that, okay? The Danfoss, which you just talked about, Henry, some of those have a felt in there. And it's kind of it's an overpressure idea, okay? So when we walk up to this, how do we know we need to change a dryer?
Pressure drop.
Pressure drop. What's a good pressure?
0.
That'd be ideal, right?
Walmart wants 5.
Okay, so above a certain point, we're gonna condemn that dryer. You just said Walmart wants 5. Anybody got any counter ideas to this?
No.
I'd say 3 to 5.
3 to 5.
3 to 5, I'm changing it.
Okay, all right. So, and I'll tell you from my experience, it depends on what type of core we're running. And if we don't know, right,
Sure.
then somewhere around 3 to 5, I'm definitely concerned. Is it creating a problem at 5?
No.
Probably not, right? My system's probably running okay. But what that's telling me is my dryer has done its job. It is full. It has collected its water, it has collected its acid, and it needs to be changed so it can continue to do that, right? I need to refreshen that desiccant so it can absorb more, right? It's done absorbing, okay? So when I start getting closer to 10, yeah, right. And we'll talk about that in a few minutes. We're gonna get, I don't know if we'll get there today. When we start talking about TXVs and pressure differential, that's when this can create a real problem, all right? Yes, sir.
Christian's wondering how long you would recommend to wait before checking on that inner core after installing it.
Yeah, right, it's a good question. So there's not a pat answer, it depends on how dirty it is. That's, the dirtier it is, the faster it's gonna stock up. So a really nasty system that's got definite contamination, say we've ruptured a heat exchanger on the hot water tank, right? We put water in this thing, and we're trying to run this. We know the system is really bad, and we're just barely able to even run it, right? I'm gonna be changing this thing or checking it 24 hours easily, right? But let's say the system is actually working, and they've been having a lot of problems. We cleaned that, we pulled the ball out of our separator, right? There's our tell. And that thing has just been, incredibly nasty. The oil's black, right? We've done a few oil changes. We're trying to clean this thing up. Our moisture indicator is still lighting up wet, right? And we're swapping cores. I'm gonna probably check that in a week. Probably gonna plan on changing it in 2. It's gonna stop up that quickly, right? Routine maintenance, and it just looks kind of nasty and we wanna help it out. Yeah, I may run the thing for a month, but I'm gonna check it about once a week.
What's the fastest you've ever seen one stop up?
I've definitely seen them stop up.
No, I mean, what's the fastest? Like how many days, like after changing, how many days?
Oh, yeah, once again, depends on how bad it is.
Okay.
But usually when we're putting these in, it's reactive to a severe problem, okay? That ruptured heat exchanger I was just talking about, for instance. My experience on changing one of them, or having to run one of these, was actually a low-temp suction rack, running 6 PSI, minus 25 degree ice cream, R22, right? Pit underground, transducer was off by 7 pounds. It was running in a slight vacuum, and it had developed a refrigerant leak. Well, the refrigerant wasn't going out, it was sucking water in.
For the project guys that are putting in suction dryers coming up to, pre-projects or whatever, would you recommend putting that in as well? And then checking it when they come back, change the dryers, pull the suction cords after the project?
Yeah, so it's definitely one of those things we can do. It's not in our spec, okay? So it's not required. Now, what's the extra cost? We gotta change the dryers before the job, right? We don't normally do that. We change the dryers after the job.
Gotcha.
But if we're doing our pre-work and we find a 17-pound drop on this thing, we have to change it before. We'll never get our case to make 10, right? So we're gonna be asking our customer to either change them themselves or give us the job, right? Which typically they're just gonna let us do it while we're in there. Well, if we're doing it then, would it make sense to throw that guy in there until after the project, since we have to change him again? Of course. Why not?
Walmart doesn't like RCW 48s, right? The high acid, old can.
What's that?
They don't like the high acid.
All right, so I'm gonna cover that here.
Oh, okay,
It's
yeah.
coming up
Move on.
very, very shortly.
Sorry.
All right, here they are.
Hey, look at that.
I have all of those on my truck.
Okay, yeah, and there's a reason why I put these on here, right? These aren't the only ones, these are spore ones, right? But you guys know there's 15 manufacturers for these. But they're all gonna react in a similar way. The challenge we have is, as technicians, we sometimes misuse these a little bit. So I wanna talk about which one we're gonna use and how we're gonna use it. So this blue one, it says high acid capacity active core. That means that guy's for acid, right?
I just had a brain blast.
Yeah, not really. All right, it's a little misleading, and this is where one of those, this is where techs go off track, right? They're just reading the literature that's stamped right on the container, right? What this guy is, this is my generic dryer. This is the guy I'm gonna run all the time.
Yep.
It is not specially formulated for acid, right? It's activated core, so it is gonna do, it's gonna help with the acid, right? It's got some of that in it. It's also a desiccant. It's going to absorb moisture. It's going to do both things, right? That's what we run a dryer for. It's gonna do both things. But this is the one we're normally gonna run. It's not gonna do either one of those jobs exponentially well, right?
Yep.
It's not dedicated to either one of those jobs. It's just a general filter that has those properties, okay? So if I've got a really acidic system, it's gonna fill up all that activated charcoal very quickly. It's gonna be used up, and it's just not gonna do any good. It's gonna do all the good it can do, and it just won't anymore, right? It's gonna absorb moisture until all the desiccant is expended, and then it's just not gonna absorb anymore. It's just gonna sit there, okay? So at that point, it's not doing anything for us anymore. So if we have a high acid or we have high moisture, we got to be changing these, right? A lot until we don't anymore, right? But this is the guy we're going to run. When they ask us to change the dryers and we're going to leave them sit, and our expectation is, you know, the maintenance guy is going to change them next year, something like that, we're running the 48s, okay? We're running the blue guy. This guy over here on the end. This is the one we're going to run, all right? So what are these other guys for, all right?
Each is for
Well, this green one is my activated core, right? Well, this one says activated core too, right?
Well, hold on, the other one on the right says activated core too.
Well, what the heck? So now it's just confusing, all right?
They're all
Yeah, they're all doing the same thing, all right? The blue one is really going after two things. It's cleaning up some acid and some water, right? This does not say moisture.
No.
We know that it says activated core. It doesn't say anything about water, all right? This guy's got way more activated charcoal in it than the other. And when we pull him out, he's gonna have black, it's gonna look like pepper.
Nice.
Right? It's not gonna be white. He's gonna have a bunch of white and black mixed in there. Right? That's that charcoal. Okay? So this guy's job is gonna be acid. He's gonna do a lousy job stopping water, right? Taking water out of the system. But it's gonna do a much better job on taking acid out of the system. It's gonna work longer before that charcoal's used up. All right? Than our regular dryer. Okay? All right, this guy down here, the gold guy, man, gold's the best.
Gold standard.
All right, I always go with the best. This guy down here, high water. Guess what it doesn't do very well?
Acid.
Acid. Okay? All right, but it's going to absorb more water than my blue one, and way more than my green one, right? So I can use that for water, right? If I've got a bunch of water in my system, I'm going to be changing the green, the gold one. All right, here's why the big red temporary letters just popped up on there, okay? My blue one has, I told you, it has a limited amount of charcoal and desiccant in it. Well, why didn't they fill the entire thing full of charcoal and desiccant? Because it'll stop up and shut off my system. It'll be a pump down, right? It'll cause my system to pump down. If I stop it up completely and it's 100% restriction, that would stop the rack from running, right? So they space that out enough so it'll help, but won't actually shut everything down. All right? When I move over to these two guys, I got a lot less of that filler and a whole lot more active ingredient. Right? What does that mean? That means my pressure drop can get substantially bigger. I can't let this thing fill all the way up, because all the way up is shutting my rack down. Okay? So when I pop these guys in there, I do need to schedule coming back and checking them and looking for that pressure drop to start climbing, and then I'm going to change it.
How are you going to schedule to come back? Are you just going to keep a mental note and be like, oh, I'm going to come back in a week?
I mean, that's a fair question. That's a process question for Kalos. How is Kalos going to manage that, right? But as a technician, if you're putting that in there, you own the follow-up until someone else takes it from you. All right? Now, let's talk about how that may go. For our customer, unless our customer is asking us to do a lot of maintenance on their store to get it all right, you know, the 666 project, right, those type things. If we're not doing that, we're just running the service call, our customer's probably going to take responsibility for changing that, right? We're going to change it because you had a problem, it was an emergency. That's why we're here. We put these in because you've got this problem. You get that in writing via text, email, whatever, with with the customer, and the customer says, okay, we'll schedule you to come back out, or our guy will do it, or another vendor will do it, or whatever, right? That's fine, we can hand off that way, okay? If we're doing that project, if we're doing this, fixing the whole store thing, we gotta keep up with that, right? That's one of the reasons we tag them, we put the date, right, that we're putting on there. If you're throwing 48s in there, maybe on that tag, you put that date in 48. Right? Something like that.
Stupid office question. They all say 48 on it.
RCW is what I put on there.
Yeah.
RCW.
So, okay, RCW, right. Put the whole model number. All right, I'm abbreviating, but put the whole model.
Gold can.
Gold can. Yes, sir.
Use it up.
So, dumb new guy question of the day. How do you, when you walk into a rack, how do you tell if you need to put in a gold core or a green core?
Right. So the tells are gonna be, and it depends on my oil type, truly, right? Mineral oil was the old school stuff. That's going away. There's not a ton of it left. But for mineral oil, I'm gonna have what we call waxing in my TXV. Okay? That really doesn't, it's not the same thing in POE.
Turtle wax?
But if we got mineral oil running low temp, particularly, it's known for waxing. Okay? What that means is my oil leaves a residue on my pin in my hole. Coats both. Well, eventually they touch, right? And my valve stops feeding because it's got this residue on it, right? Now, I can add hot water to that, and that residue becomes viscous again and flows out, right? And this is why you see, techs dumping a bucket of hot water on a valve that starts feeding, and guess where he's going, right? He's gonna throw in his cleanup dryers. He's going with greens, okay? Now, on POE, moisture is what causes my acid. It's a totally different type of setup. So if I run my acid test on my oil and it fails on POE, I've got acid, there's one of two things that's caused it. Either high moisture or high heat, right? So my compressors, I could have a bad valve plate and I'm recirculating that oil. I could have fins out on a condenser, or fan motors even, lack of maintenance, where I'm running hot, right? So one of those two is caused my acid, right? I've got to clean up the acid, so I'm going to be running greens, but I may have moisture also. Okay, I need to know which. So I'm going to go to my sight glass, which is farther in my slides, to know. Okay, which of those two?
Is there a field test that we can do, like a sort of test kit that would tell us, hey, we're struggling with moisture or struggling with...
Not for moisture, but it will for acid. Yeah, absolutely. Yeah, and that's part of a regular maintenance.
How often is that regular maintenance?
So best practice is once a year. I'm gonna run an acid test once a year on my, and I'm testing my oil is what I'm testing.
If we walk up to a store that, like a 666, that we're owning this until we're to X percentage.
Right.
Is that something that we should be implementing every time, saying, hey, we're just gonna check these things along with our pressure dropper processor drives, along with our efficiency tests,
Yeah,
et cetera?
when we're developing that scope of work is the time.
Okay.
Right? So we're gonna evaluate the oil, right? We're gonna look at it. Is it black? We need to change oil? Yeah, then it's probably acid time too. Okay, it's most likely gonna be both. They go hand in hand with POE, right? With mineral oil, not so much, but POE definitely.
What would be some symptoms of like acid contamination that you would see without being super invasive? Like, is there anything that you would walk up on and just like suspect that there might be acid contamination in the system?
Yeah. So when you say contamination, it's a dangerous term. Contamination is anything other than what's supposed to be in the system. Non-condensables are contamination. Totally different set of symptoms than what we're talking about, right? So what we're talking about is really acid and water. Those are the two main things that these are going to help us with. So he just said, what would I suspect if I had acid issues? Well, the most obvious would be my windings are failing on compressors and it's not bearings. Right? If I'm washing out bearings and that rear bearing sits low and my winding touches the stator and shorts it out. That's not the same thing as acid eating through that very thin lacquer on all those wires, and I've got a short, but my bearings are fine, right?
Okay.
Totally different scenario. So there's not a lot of things that would show me that other than that.
Right.
That's why we do an annual acid test on the oil, to get ahead of that before it happens, right? But if that happens and we've missed that acid test, or I say our customer has failed that requirement, okay? And now they're actually losing compressors. When we get a shorted compressor, you've heard every compressor guy ever tell you why. You got to find out, why did it fail? Hey, well, this is part of that, right? If I go through my checks on my compressor and all my bearings are fine, my valve plates are fine, I check the electrical, my contactor's fine, all that's good, and I've got a shorted compressor, hey, acid test. Can I run these on the suction side?
Yes.
Yeah. Yeah, they'll work the same, okay? I can run this on liquid, I can run this on the suction. Will they work as well? Yeah, actually, they don't do bad at all. Why don't we normally do that? Why do we use a sock instead, a felt?
Because you don't want little bits of desiccant in your compressor.
Pressure drop.
Yeah, like that.
Right, my screen should stop the desiccant from hitting my compressor, if I installed it correctly, right on that drawing.
Yeah. They don't know.
All right, but I'm gonna have pressure drop, okay? So can I, if I've got that high water problem that I was talking about, can I stuff these into my suction?
If you want it faster.
Sure can, right? Sure can. Help clean that up faster.
Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. And while you're at it, join our thriving Facebook group. Also, don't miss out on our free mobile applications available for both iPhone and Android. We're all about community. For techs, by techs.